Here's another function. It has been written in intercept form. Now, intercept form means it's written as factors. You could be given a quadratic function which you then can easily factorize, in which case you should do to get it into intercept form so that you can work out the x-intercepts. But if you can't see it working very well, there are other methods that you can use. Not every quadratic function can be factorized, because if it doesn't have any x-intercepts, like for example this graph or this graph, then you won't be able to factorize it. So just be mindful of that. So what happens if we have it? If we have it in this form, or we are able to manipulate it into this form? Well, we go through our 4 steps again, and let me show you how they kind of work out. So the 4 steps are: number 1, work out the shape. And the shape, remember, is determined by the value, like in the general form. I'll rub this out in a second. It's this, isn't it, that determines the shape, i.e. it's the sine of the x squared term. The sine of the x squared term. So looking at it in intercept form, I'm not going to expand it at all, but what I am going to do is I'm just going to note that I've got a minus x here and a positive x here. So that's minus x squared. And so I know the shape is going to be frowny, concave down. You've got to be careful. If there's a number in front like this, for example, then if you were expanding this, it'd be minus x times x is minus x squared, and then the minus 3 would then turn it back at positive again. So be careful. It's the combination of the sign of this factor here and this factor here and this factor here. So just be mindful of that. Okay, so we've got our shape. Number 2 is to work out the y-intercept. Doesn't matter the order you do them, by the way. I'm just doing them in this order for the sake of it. We let x equal 0. And so if we do that, we get y is equal to, you can do this in your head. I'm just spelling it out for the video. 0 plus 4. So we're going to have 2 times 4 is 8. And so the coordinate is 0, 8. X-intercept. It's in the intercept form, which is really handy. So for the x-intercept, where we let y equal 0, we end up with 2 minus x plus 4 equals 0. Because it's already been factorized by the null factor law, we can say that 2 minus x equals 0, so x equals 2, and x plus 4 equals 0, so x equals negative 4. So if it's in intercept form or can be easily turned into intercept form, working out the x-intercepts is pretty breezy. Now, the turning point. This is where it gets a little bit more interesting. The turning point, when you've got the x-intercepts, is probably most easily got by averaging out, well, not averaging, but finding the midpoint. So you've got 2 here, and you've got minus 4. Oh, that was dodgy. I mean, want it? Try that again. Minus 4 over here, and you've got 2 here. Then where's the midpoint of that going to be? Well, there's a distance of 6 between these, yeah? 4 to get to 0, then 2 more. And so half that distance is equal to 3. And so the midpoint is going to be at minus 1, 3 units on. And you can see here that there's another 3 units here. Now, the reason why this works is because the parabola is symmetrical. So if there are 2 x-intercepts, then looking at the distance between them and halving it will give us where the turning point is. It'll be the mirror part of the thing. So x is equal to 3. To work out what y is, we simply substitute it in. 2 minus 3, 3 plus 4. 2 minus 3 is negative 1. 3 plus 4 is equal to 7. So we've got negative 7. So the turning point is at 3, negative 7. That's our 4 pieces of critical information. Now we can graph it. So again, excuse my dodgy drawings. Our x-axis, we've got our y-axis. We've got our turning point, which is effectively our axis of symmetry. So I might even put that in. I don't often do it, but I should do. Oops, I've got to go back, don't I? I'm not going to redo this video because it's not worth it, but I need to go back because I've stuffed up a little bit here. The turning point isn't 3. 3 is the number of units I had to shift across, but the turning point is actually -1. Like so, because that's the midpoint between -4 and 2. Nope. So let me just and I'll quickly do that substitution again. So it's 2 minus -1 multiplied by -1 plus 4. So that gives me 2 minus -1 is 3. -1 plus 4 is 3. And so the y-intercept is 9. So we've got -1, 9 as our turning point. Oopsies. So at x equals -1, we've got our axis of symmetry. Okay, so I'll label that x equals -1. I have one of my x-intercepts at 2, 0. So that's 2, 0. I've got my other intercept at -4, 0. I've also got my y-intercept at 8. So that will be, yeah, I'm not going to do a very good job here, am I? Because I've really skewed it. So I'll just call that 8 there, or 0, 8. And just checking, looking at this, I kind of looks like I have to do this. It's not going to fit if I go smiley. So it looks like it's frowny. I did work out the shape as being frowny, so that's good. Always really handy to double check that because it's really easy to muck about with the values here and accidentally get them around the wrong way. So by doing a double check that yes, these values fit the shape that I worked out before, really handy, I reckon anyway. Now you're going to do a lovely smooth graph like I'm not. So, the turning point, sorry, was -1, 9. So -1, and then, so it's something like this. -1, 9. Kind of handy to have that in there as well. Okay, and let's see if we can make it all happen. Gosh, that's wobbly, isn't it? Yeah, wobbles aside, we've got a sense of the graph here. Okay, so the usual 4 critical points. I think you could agree that getting the x-intercepts was easy, y-intercept wasn't too bad, shape was okay, turning point required a bit of thought work, but you can get there. Next video, we'll have a look at sketching using the quadratic formula.